Yes. Okay, so my name, you can't really see the name spot, but my name is Mr. Call, so make sure you write your name in here. Okay. You don't have my name?
We don't. We do not have a nombre.
Oh, well, write on your nombre anyway. Write your nombre down anyway.
What's the correct answer?
Okay? Yours is going to be Bill. Okay. All right, guys. So, in this chapter, we're going to talk about... Okay, we're going to be talking about different properties of triangles, okay, and triangle similarity, okay? We're talking about congruent triangles, and we're going to talk about similar triangles. That's going to come later in the chapter. For now, we're going to talk about different properties of them in different parts. So we're going to talk about perpendicular bisectors and angle bisectors of triangles to start, okay? We talked about perpendicular bisectors and angle bisectors in general, so now we're just going to apply them to triangles. Perpendicular bisector is a segment, ray, line, or plane that is perpendicular to a segment at its midpoint. So it ends up cutting the segment into two congruent parts. That's what the bisector part means, right? And the perpendicular means that it intersects at a right angle. So in this picture, what is the perpendicular bisector of what?
C is the perpendicular bisector of A and B.
Okay, so segment AB is being bisected, and what's doing the bisecting?
C.
Line CP. Line CP is bisecting perpendicularly, so it's a perpendicular bisector of segment PB. We can tell segment AB, is cut in half, and it's perpendicular. Yes.
I need to know who made this. Like, was it you or somebody else?
Somebody else made a lot of these, and then I retooled a lot of it.
Okay, why in the world does it have A, B, C, and then a P?
P? Yeah, I don't know why.
Yeah, that's sort of dumb.
But like when I saw it, I'm like,
P for point.
maybe. Why wouldn't it be M then, right? You know. Anyway.
Other jobs.
Yep.
There's
also an X there.
What?
There's also an X there.
Somebody else made it
You
because you were
couldn't
too
make.
busy
You had to have
getting
someone
new
else
job
make
interviews.
this because you were looking for other jobs.
That's totally it. Yeah, you caught me, okay? So, perpendicular bisector theorem, because we have theorems for everything, okay? So, if a point is on the perpendicular bisector of a segment, so if a point is on the perpendicular bisector, so once again, the perpendicular bisector was line CP. So, in this case, line CP or CP and X could all be a point on the perpendicular bisector of a segment. Then it is going to be congruent, or you can just do the symbol or write the word, from the two endpoints of the segment. So we're saying here, X, P, and C, they are all on the perpendicular bisector of the segment. They're all on the perpendicular bisector. So any of these points, we're going to talk about C right now, are congruent or equidistant, the same distance, from A and B. Excuse me, I said the word congruent there. I messed up. That's supposed to be the word equidistant.
Wow. Wait, well, that's kind of depressing. How can we shorten that?
You don't. Okay? Equidistant's already a shortened form of equal distance.
Can I do equal?
No, you can do equidistant.
I like equal.
No, you can do equidistant. Okay, Aiden.
And this is kind of off topic, but can you make a line bigger than another line? Like,
No, great question. Two lines are going to be the same length because they have no length because it's infinite, which is just a concept.
so
And they have no thickness, so they can't be thicker or thinner than another line.
how do you
How
make a
big
plane
is
that
thick?
goes forever?
It goes forever.
Yeah, but how do you know? How do you up that?
Because they
Uh, Yeah. Well, but in a plane, you just don't draw arrows because otherwise it's going to be a big mess. So it's just implied.
But how do you know if it's not?
Nobody asked you.
I might send you back to chapter 1 and watch those videos. All right.
I'd like to go back to chapter 1.
So, nice. Okay. So, meaning, guys, that these are going to be the same length. Now, we could also do the same thing from A to X. And B to X would be the same length as well, because X is also on that perpendicular bisector. So, it's going to be congruent to those two endpoints as well. And did we end up really forming a couple triangles?
Are you making a circle?
Okay. No, those were supposed to be triangle lines. It was just really bad.
Take a screenshot.
No, I don't have that on this. It's only if I do a screenshot and then I can't record it. But then I can't record it.
I think that's worth it.
Okay. Continue on.
Yeah, whoever's gone doesn't need it.
We have a converse as well. A converse as well. Okay, converse means you go the other direction, right? We're not just talking about the shoes, okay? So, the converse, we're going to go the other way around. So, if a point is equidistant or the same distance from the endpoints of the segment, so if x is equidistant from the endpoints of a segment, then we know it has to be on the perpendicular bisector of the segment. And you could write out perpendicular bisector if you want, but I'm not going to. Okay.
Of the segment.
So the converse of the perpendicular bisector theorem says, hey, x is on the it says, hey, x is equidistant from the two endpoints A and B. So it has to be on the perpendicular bisector. So even if you didn't see this perpendicular bisector there, because it's equidistant from those, we know it has to be on the perpendicular bisector.
Then X is away.
The next is what?
Away.
Array?
Yeah.
Oh yeah, we would have x some other thing be a point. Yep. We could have it be on the perpendicular bisector if you were to extend it. I thought you had your hand raised, but you're just holding your head. All right. So if XA, segment XA, is equal to segment XB, so if it's equidistant from those, is what that's saying, then X lies on the perpendicular bisector of segment AB. It lies on the perpendicular bisector of segment AB. It's bisecting the segment. I know. Makes it even better when I crush you down.
Oh.
And then leave us.
No!
We're gonna get left again.
Y'all.
They brought us down.
I know y'all have these deep-seated trust issues.
No,
But y'all, I'm still here.
yeah, for now.
That's what they said.
Mr. Wallace left my grade. I think he can stand you guys.
And then
I don't think
some
you
of
know
that
that.
teachers we wish
We've
left, but
been
they
called
didn't.
the worst.
We are the
My
worst,
grade
guys.
made 2 different cults for him and Mr. Howard.
They were pretty great, though.
It was pretty bad.
Wait, were they always at war with each other?
It was a weird time.
Yeah.
No, that's just a cult of math teachers.
I have
that are just
cult.
like gonna like
Yeah.
overthrow the school
Yeah, Max.
eventually.
And you're part of the claim, alright?
How did you know?
Me and Max are in the same cult.
Alrighty. Example 1. In the diagram, line RS is the perpendicular bisector of segment PQ. Line RS is the perpendicular bisector of PQ. And we're trying to figure out PR. Excuse me, PR. I quoted the wrong one. PR. How can we figure that out? Okay, Gage.
8x minus 9 equals 6x.
Okay, that is the correct equation, but how can we know that that's true? How can we know we can set this one up? Gage.
Because if it's the perpendicular bisector,
Yep.
and it's on the line of PQ or something.
Okay.
then we know that they're the same distance from each other.
Okay, so because R is on the perpendicular bisector, it's equidistant from those endpoints. Is that what you're trying to say, kind of? Okay. So then, since R is on the perpendicular bisector, we're told that it's equidistant from these endpoints. So we can set them equal and solve. Yes, Aiden?
4.5 units.
Okay, so it's going to be 8x is equal to 15 divided by 8.
No, you didn't.
Yeah, you have to put 6x.
Oh my goodness.
What doing? What doing?
What doing? Why say lot word when few word do trick? There we go.
Mistakes like that.
Sea world.
Travel ocean. Sea world. Okay. Negative 9 is equal to negative 2x. Let's try this again. Divide by negative 2.
Okay, maybe not.
X equal to 4.5.
Next thing you know, you're
So now how do we find the measure of PR?
It was supposed to be 4.5%.
Yeah, that's okay.
It's not the question on the
I'd see if there's a proof that would be wrong, but it's not a
Oh,
proof.
proofs. Don't.
All right.
Isn't it 4.5?
What do we do with this 4.5 now?
Sure.
Plug it in.
Plug it in where?
To the x.
What is under?
Now it really doesn't matter.
Uh-uh.
It shouldn't as long as we did it correctly, right?
Do not care.
Okay. So which one do you want to do it in?
6.
Okay, so 6 times 4.5
No way.
is going to be
6. 26.
27.
Oh, dang.
Gage, I know you like the number 26, but that'd be 27.
Okay, actually I should write that as measure of segment PR
Oh, no.
is equal to 27.
No.
Yes.
Technically, this is
Yes.
Not labels.
See.
Okay. See. All right, let's go on to example 2. Oh, what's your question?
Does that mean P and Q, angle P and angle P, angle P and angle Q are equal?
That's correct. So angle P and angle Q would be congruent here because the big triangle is an isosceles triangle now. Yep, that is big brain. All right, example 2. Checkpoint. In the diagram, line JK is the perpendicular bisector of segment GH. What segment lengths are equal? Who can raise your hand and tell me 2 segment lengths that are equal in this example? Okay, Aiden.
J, G, and JH.
JG and JH would have equal measure, so JG is going to be congruent to JH because if it's on the perpendicular bisector J it's going to be equidistant from those 2 endpoints. Okay, what other segment lengths might be equal? Okay, Bill.
GF and HF.
Okay, so assuming this goes up and goes through there, but wait, we can also know that because these are equidistant. F is equidistant from these 2. So GF and HF are marked. Okay, what else? Kaya? GK and KH are congruent. Because GH is bisected. So those are congruent. Okay. Anything else we know would be congruent?
Probably.
JK.
You can say JK is congruent to itself, right?
Just kidding.
Yeah. Otherwise,
No, that was a joke.
oh, da.
Did you not get it?
Da. All right. How could we find the measure of segment GH?
By adding.
Hi, Danny over here, Mr. Carlson. Nice to meet you. Gage.
Math.
G 2x equals x plus 1.
Okay. How's this going to help us big picture?
X.
You plug it in and you add it.
Okay. So this is going to help us find each of these individually, then you can add them together, right, to get all of GH. Okay. So subtract x, and x is 1. Plug it in, you get 2, and you get 2. So what's the measure of segment GH?
4.
It's 4.
Yay.
Math. Quick math.
Question on that. 2 plus 2, that's 4, minus 1, that's 3. Quick maths. Alrighty. Continuing on, if there's no questions on that. Look at the following picture. Segment AB is a perpendicular bisector in each of the following triangles. But what do you notice about these perpendicular bisectors?
They're not
I
in the
can't see
middle
one of them.
always.
Yeah, one completely black.
What do you mean about, okay, what about up here then? Okay, what do you mean by they're not in the middle always?
We don't hit the middle.
They're not the same. They're not the same cut in half.
Okay,
The same
Kelly?
surface
They
area.
don't go to the vertices of the triangle.
Okay, they didn't go up to the other vertex of that triangle necessarily, okay? So these don't go up to that other vertex, the opposite vertex of that triangle. Is that kind of what you guys are trying to articulate?
Yeah.
Okay.
What
So,
did you say?
is that what you guys are trying to say?
Yes.
Okay. Articulate just means say. Anyway, yes. Okay, they do all have right angles because they're perpendicular bisectors, right? All right. So we notice though they don't all go to their vertices, and that's okay. Okay. So this is something I want to say. I want you guys to write in there. The perpendicular bisector
All caps, yes.
does not or doesn't have to go through the vertex of the triangle. It doesn't have to go through it to be a perpendicular bisector. It can, and the examples we've seen before this did, but it doesn't have to. And we'll imagine that triangle is just better drawn. There we go. It's a thick boy. Yeah, Aiden.
So you said you're lazy and you like to squish everything together, right?
Sure.
You said does not. You just said doesn't.
I know.
You lied to us.
Well, no, I didn't lie to you.
lied to us.
I just had a moment of temporary lapse in judgment.
Wait, you lied to us here?
Yeah.
No.
Maybe you lied to us about something else. You
There
are
it is.
leaving.
There it is. There it is. I knew that's where we were going with that. I knew that's where we were going with that.
And all the people that left us lied to us.
And Miss
Okay.
Rome said she wouldn't leave.
Same with all the other ones.
Yeah, she was gone after like 2 weeks.
Yeah, it was 2 months and then she was gone.
Yeah.
Mr. Wallace said he had a court.
I saw her dip. She like sprinted. It was not.
She hated
was
us.
happy.
And then she broke Max's arm on purpose.
Yeah, she broke Max's arm.
What?
I broke my arm in half.
Oh yeah, he did. He fell down a hill. He fell down a hill.
And she broke your arm.
On
It
her
was
last
her
day.
master
It
plan.
was her last day.
That was a good.
It's her last day.
Yeah, that's why she
Dropped
quit. She
too.
broke your arm.
We were just doing it.
Yeah,
that was. No, that
Alrighty. That does sound like Miss Rowan to give you guys recess on the last day. That is the thing she would do. All right.
She quit.
We're gonna skip this for now because of the Rona.
What?
We might go back to it. We might not. We'll depend. We'll see how we do it.
Wait, it's not just Oklahoma or something.
Oklahoma.
All right.
I
We're gonna talk about an angle bisector theorem. Okay. If a point is on the bisector of an angle, then it is equidistant.
Big word.
Can we just put equal distance?
No.
Oh.
Then it is equidistant from the two sides of the angle.
Equal distance.
They're equal distance.
Okay. Now, distance is going to be measured along the perpendicular. I'll talk about what that means. Okay. So, we're saying if a point's on the bisector of an angle, if point D is on the bisector of this angle, which we see it is, these angles are congruent. If measure angle BAD, or really it should be DAB, okay, is equal to the measure of angle CAD, then measure of angle or measure of side DB is going to be equal to the measure of side DC. And if you wanted to, you could also just say segment DB is congruent to segment DC. Either way, you're saying the same thing. You're saying, hey, it's equidistant.
Yeah, that's what it shows. I don't have anything. Yay.
Okay? And it is what it shows there on the picture. Okay? And now notice, it's measured at a perpendicular angle on the side of the angle. Remember, the sides of the angle are the two parts of the angle that kind of go out, the two rays of the angle, okay? So ray AC and ray AB are the sides of the angle. It's perpendicular to that because perpendicular is going to give us the quickest route to that angle, okay, to that side of the angle, okay? Your quickest route to something is going to be where it's perpendicular to something, okay? So if I am walking to, let's say, the wall over here, okay? People watching a video obviously can tell this one, okay? But if I'm walking to a wall over here, okay? My quickest route is not going to be going over here, will it? Okay? I touched the wall still, but it's not my quickest one. What's my quickest route?
Go that way.
Going directly to my left, okay? And touching the wall right here, okay? Or actually touching the wall, not the air, okay? But going at a perpendicular to me. I'm going to go 90 degrees to where I'm at versus another angle to that, okay? Or another angle to it over here, okay? So same idea. It's going to give us the quickest distance, and it's also going to be a consistent distance, okay? Whereas if we say we have it at a different angle, Max, put it away. Whereas if we have a different angle, like it's over here, and we just don't know what the angle is, and this one's over here, and we don't know what the angle is, then we can't necessarily say, oh, if those are equidistant, that tells us anything. Alrighty. We have the converse. We might clear up a confusion in a moment. We'll see. If not, we'll go back, okay? So if a point is on the interior of an angle, so if D is on the inside of an angle somewhere, and it's equidistant to the two sides of the angle, which it is, then it lies on the bisector of the angle.
I don't even put the period. I'm that lazy.
Okay?
He lies just because he's not lazy.
So because D's in the middle of this angle, the interior, and it's equidistant from the two sides, once again along the perpendicular, then the measure of angle DAB, I'll say it right this time, DAB, is going to be equal to the measure of angle DAC.
Dak Prescott.
I think so. Hey, just because it's true doesn't mean you have to say it. Okay. All right. Any questions on this before we start using it? Yeah, Aiden. Okay, good talk. Alrighty, continuing on.
Where's the line?
It's not there anymore.
Oh.
All right. So decide whether this information on each of these 1, 2, and 3 is enough to conclude that C is on the bisector of angle A. So number 1, do we have enough information to say if C is on the bisector of angle A or not?
No, there's no line. There's no line.
Let's go back to our converse. What's the converse say? Yes, because these are right angles. And what do you know about the distance? The same. So is C inside? See, no, this is a different color. Is C inside these two, the angle?
Yeah.
Okay, so it's on the interior of the angle. And is it equidistant from the two sides?
Yeah.
Yes, it is. So is it on the angle bisector? Yes. Okay, so on this first one, we know it is. According to the converse, that fits it. What about number 2?
No.
No, why not?
It's different lengths.
It's not equidistant. It's not equidistant from these two sides. It's perpendicular, but it's 4 centimeters and 2 centimeters. Not equidistant.
How do we know it's not?
No, but it might be
8 says 2
equidistant.
centimeters.
No, it's not because it's away from 4 and 2 at the perpendicular.
The 4 could be from that.
No, Aiden.
No, it's but then that further proves it because it's farther than 4.
No, but it's
Aiden,
like
no.
So if it cut in half, that means the little hump right there could be 2 centimeters and 2 centimeters, meaning it's equal distance.
Huh? If you cut it in half, there.
No, you're saying equidistant from this one, but that's not the angle we're talking about. Even that's a stretch, but we don't know that, and we also don't know that that one would be a right angle that you're referring to.
Lowest centimeters, 2 centimeters and 2 centimeters, meaning those aren't equal distance.
Nah, that works, buddy. All right, let's look at this one.
No.
Why not? It's.
They're not based on.
Whoa, wait. What did you say?
You don't know the angles.
You don't know the angles. You don't know if the angles that it's meeting the sides at are perpendicular or not. If you knew those angles were even congruent, it could be enough. But they aren't. You don't know that. Maybe they are. Maybe they aren't. They're not right angles. That's what we know. So this is not enough information. So even though, regardless of whether it looks like it, positionally, we don't know whether it is or not, because even though it's equidistant, we don't know what kind of distance it is, if it's a perpendicular distance or not. Okay? Very good, Sierra. Aiden.
C.
No.
Okay. Any questions on this one
Why?
that have not been asked? Yes.
You sort of skipped out on the pink on Wednesday.
Oh, that's what you think.
It's very.
Yet you see this paisley tie, which is what color?
It's
He
skimpy.
lies to us.
It's a sign.
Salmon. Salmon.
Barely any pink. He's
Salmon.
He's not as into
Salmon.
as he used to be.
Okay. Just a few more examples here, guys. So, example 4. Let's find the measure of segment CD, okay? We'll do this one together. Now, we know point D is on the bisector of the angle because we can tell that these angles are marked to be congruent, correct?
Yes.
So, what do we know about point D compared to the sides B and C there?
B and C.
It has to be equidistant from those. These segments have to be congruent, not only because they're marked, but because they're right angles, and it's on the bisector. So what can we do with 3x plus 5 and 6x minus 7?
Equal each other.
Set them equal.
Do math.
That's true.
Good stuff.
But this is geometry.
X equals 4.
Gage is right. Somehow.
And x is what?
4.
Is that our final answer?
Yes.
No,
Just
plug
dealing
it
with
back
that.
in.
No, we have to plug it back in. Where do we plug it in at?
The X's.
Dx plus 5 because they're.
Okay. It doesn't really matter which one, right? Now, sometimes if you want to check, hey, plug it back into both. But because these are congruent, it really shouldn't matter, okay? So Aaron, put it away. All right, so if we plug it into 3x plus 5, we get 12 plus 5, which is 17. So the measure segment CD is 17. Does anyone need to see that written out?
Anyone who's ever taught us algebra left us.
How would you do that so fast?
Yeah, the math teacher that left us favorite thing to say was plug it in.
Oh, that is true.
That's facts. There's too many connections.
Which math teacher that left? There's too many to count.
Oh.
Okay.
Oh no.
Example 5. How could we find x here? Mascara knows.
Like Michigan or something.
Shut up, Liam.
Hi, Gabe. Bye, Gabe.
He has a pretty successful YouTube channel. Not as successful as Timothy Crawford.
He has a successful song, the Pythagorean theorem song.
Oh no, don't even.
Okay. Example 5. How can we find x here?
You just can't.
They equal each other. They're congruent because this point is going to be equidistant from these two sides of the angle at the perpendicular. So the angle is bisected. So we set them equal. X minus 5 is equal to 2x plus 5.
So it's
Wait.
so it's 5.
It's math.
It's
It's 10.
Keep doing the thing.
I got it right.
X is 10. It's true.
Oh my god.
That's true.
Are we done?
Facts. No.
Yes.
No.
It says 5x.
Yeah, it just says find x. We're done.
Ah, silly use.
Yeah, silly goose. Yeah.
Can you skip the thing ahead and just simplify the entire thing and say 3x plus 2x equals minus 5 plus 5.
I bet Max already has example 6 done.
No, because you did it wrong. You can do 3x minus 2x is equal to 5 plus 5.
I bet you have example 6
No, I don't have any.
Wait, look at that.
No, because 3x is
I mean, I can do it.
positive and 2x is positive.
Huh?
Yeah, but they're on different sides of the equal sign.
Oh, still works.
So we have to subtract them.
Oh yeah.
Alrighty. I want you guys to do example 6 on your own. When you have it or have questions, raise your hand. Okay, guys, big picture. This angle is bisected. This distance is perpendicular, so it has to be congruent to the point that's on the bisector. Set it equals 7x plus 3 equals 8x. Subtract 7x. 3 is our x. Do we have to do anything else?
I didn't do any of that.
No. Yes.
You didn't need to write down the equation because they're right next to each other. And if you
Sure, if you want to do mental math, you can do mental math.
Take out 1x.
Here's the thing. If you do mental math on your test or something like that, and you get it wrong, can I give you partial credit?
No.
No. So it's a risk. You're allowed to.
I take the risk.
It's a risk.
That's what I did on my extra credit. I wrote down stuff. I got the answer wrong, but I still got plus 2 points.
I guess.
How handy.
Facts.
Alrighty. Anyone have any questions on this? Yes.
We should watch the inauguration.
No, we should watch Phineas and Ferb.